Okay, so this is the memo for tutorial test number 2. So again, we got this selection of compounds, they're all natural products actually, variations on them, and so we need to answer the questions. The first one said is we were looking for a cyclic ketone whose chiral center has the R configuration. This question actually has a slight mistake in it, in that there's actually two possibilities. So if we look, this is a cyclic ketone over there, there's a cyclic ketone over there, and these are also cyclic ketones over here. Now, technically speaking, it does talk about it has a chiral center, which the implication is it's only got one chiral center, whereas this one has two. But that's not terribly clear over there, so it's not important. What we're really wanting to do is assign this center over here. Once we know what this center is, we can then say, okay, must this group be up or down, and then we can choose it correctly. So it needs to be R. When we look at this, we're going to number it. We go carbon, 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 no difference. This carbon goes to another carbon. This one goes to another carbon. This one goes to double bond carbon and a single bond carbon. So this one wins. It gets number 1. So carbon, carbon, no difference. Carbon goes to carbon, carbon goes to carbon, no difference. This carbon goes double bond to oxygen. This one only goes to carbon. So this side is number 2. This side is number 3. So we look at this and we're going 1, 2, 3, we're going in the right direction, R, which is what we're looking for over there. So this one over here is correct. It's an option for this one. But likewise, this compound over here at the top, D, is also a correct answer, and so is also worth 2 marks, because there's not both of those really do satisfy the answer for that over there. All right, so the next one is a meso compound. So we're looking for planar symmetry, which should actually be very easy to find. All of these, there's something that might have an option, but actually if you look at it, those two are not the same on either side, so it can't be that one. But no, these are not symmetrical markers. Wait a second, this one over here, however, it does have a planar symmetry, but all these things over here are not even remotely symmetrical. So that one should have been a very easy one to find. And so it's compound F, it's not a chiral molecule. Now we're looking for a conjugated aldehyde whose alkene has the Z configuration. So it needs to be an aldehyde. No. Yes, it's an aldehyde. No. Yes, it's an aldehyde. No. Okay, so clearly those are the two, and they're very similar to each other. Look at that. And we need it to be in the Z configuration, and it's going to be, those are neither E nor Z, but this one over here is E, because highest priority. This one over here is Z, highest priority on the same side of the double bond. So the answer there is G. A conjugated ester whose alkene has the E configuration. So we're looking for an ester. No. That's an amide. There's an ester over there. All right, amide. No. Aldehyde, amide. No. There's ester over there. No. And there's an amide over there. So the options are either C or I, and we're looking for a Z configuration. Sorry, an E configuration, my apologies. And so that must be that one over there. That's definitely E, whereas this one over here is Z. So the answer there is I. And then the last one, it needs to be an amide containing compound whose secondary alcohol has the R configuration and whose second chiral center has the S configuration. Okay, so a little bit more complicated, but where are the amides? None there. So this is an amide over here. This is an amide over there, and there's the other amide over there, and there's one over there. So there's 4 options. So what we need to do is we're going to look at this amide containing whose secondary alcohol is the R configuration. Let's figure that one out first. So there's the secondary alcohol in all of those. Let's choose this one because it's easy to do, because the H is going to the back. So it's 1 over there, then carbon goes to carbon, carbon, no difference. This carbon is double bonded to carbons, but this carbon has got to a nitrogen. Nitrogen wins. So that's going to be 2, that's going to be 3. So this is going 1, 2, 3. We're actually going in the R direction. So the OH has to be pointing out. So that immediately discounts this one over here and this one over here. Our options must be between A and H over there. So the next thing is the second chiral center must be an S configuration. So we're going to have a look at that. Let's do it over here because the H is pointing to the back. That'll be easier. So nitrogen wins over the 2 carbons, so it's a 1. Then we go carbon, carbon, carbon goes to oxygen, carbon goes to oxygen, but this carbon also goes to another carbon, so it's going to win. So we get 1, 2, 3. So this one is going round to the right. Okay, so this one is R. So actually, our other option must be this one over here. So because this one must be going, it is in the opposite direction. So the answer here should be H. All right. Okay, so this one takes a bit of time to work out each of the things. That's why there is 2 marks per question. The rest of these are fairly, should have been fairly simple. How do you draw out an enantiomer? You must just reverse everything. That's the safest way of actually drawing it out. So the OH is coming up, and the NH2 must come up as well. When drawing out a diastereomer, there are 2 options here because you just need to reverse one of them. So I will just draw one option. I'm going to make the NH2 come up, but I'm going to make sure that the OH is still pointing towards the back. But of course, this could have been up and this is down. That would have been correct. So 2 marks each, very easy marks to get over there. That's core knowledge stuff there. Okay, assigning priorities. This is something you should be able to do. It's not core, but this is for stereochemistry. You should be able to do it. We've got carbon, 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 no difference. Carbon goes to bromine, carbon goes to hydrogen, carbon goes to carbon, carbon goes to carbon. Carbon to bromine is going to win. Carbon to nothing, just hydrogen, is going to lose. So now we've got a difference here. Carbon goes to carbon, carbon goes to carbon, but it's double bonded, so it's going to win versus this one over here. Even though the sulfur is bigger, it's too far away. Our decision stops there. We had carbon, and there's a carbon. This carbon is a single bond to carbon. This is a double bond to carbon. It wins, so we don't have to go any further. Do this again. Carbon, 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 carbon. Carbon goes to carbon. Carbon goes to nitrogen. Carbon goes to carbons. And carbon goes to oxygen and nitrogen. Oxygen is always going to win, so that's going to be number 1. Then we had one that went to nitrogen, so that must be number 2 because the rest all went to carbons. So this carbon goes to carbon, carbon double bond to carbon and single bond. So this one has to be 3 and this one needs to be 4 over there. This one over here, carbon double bond to oxygen, that really looks very high. Carbon goes to carbons, carbon goes to oxygen and nitrogen, carbon goes to carbon. So these 2 are the ones we're going to be looking at, but this is effectively 3 bonds to oxygens, and this is 1 bond to oxygen, 2 to nitrogen. Oxygen is higher, 16 versus 14. So this one is going to win, and this must be number 2 over there. Then over here, we've got carbon goes to 3 carbons, and this carbon goes to 1 carbon. So this one has to win over that one over there. All right, so make sure that you can do these Carnegie Prelog rules. These are important things to be able to do. Okay, the new stuff for Chemistry 214 is this type of work here, being able to do Newman projections. It's really important. So when we look at this, we're sticking our eye over here, and we're looking down this bond over here. So there's the bond that we're looking down, and as we look down, this one is in the plane, which is over there for us, so we can put the other 2 bonds there. And at the back, the circle represents at the back. At the back, this over here, this group over here is pointing straight down. It's an ethyl group, so we can write it in. And the other 2 are sitting over there. So this is a methyl. As we're looking down, the bromine is on the right-hand side. It's coming above the plane. This is our plane of the paper over here, straight up, straight down. So this side is above the plane. This is below the plane on that side for what we've drawn. And so that must be an H, and there's just 2 H's over there, so it's a bit boring. It's easy to put that one over there. Okay, now we're looking down the other, sort of another angle, going down that side. As we look down this way, the bond that's in front of us is going straight down, all right, to the carbon. So the other 2 are coming up like this. So draw a circle for the back, and at the back, what's going in the plane, going straight up, is the nitrogen, NH2. All right, what's coming is just 3 carbons. That's a propyl. We can write PR for that, or you can draw them out. It's fine. And as we look at that over there, So this is the plane of the paper. Everything that's below the plane of the paper is over here on the right-hand side, and above the plane of the paper is on the left-hand side over there. So there's an OH is below the plane, so that must be an H over there. And the other two is just two hydrogens, so it's very easy. Last one, most trickiest, because we've got two chiral centers over there, but it just follows the same rules, and we should be able to do it. As we're looking over there, this is coming down in front of us, so that's the part of the plane of the paper, or circles, so we can fit the other things in like that. What's coming down, that's a CH3. As we look down there on the up is on this side. There's our plane of the paper running north to south. So this is the top, this is the bottom. So the NH2 is over there on the top. This one's on the bottom over there. And then we've got a CH2OH, so we can write that over there going up. And above the plane is a CH3, and we've got an H over there. Right. But we need to be able to do the reverse of that, to take a structure that looks like this. So all we need to do is we look at this, we can see there's the main chain is CH3 going to this carbon, the next carbon is the one behind the circle, and the next carbon is this over there. So if we were looking, it's basically CH3 is going down, down, it's the zigzag, where we're looking down this bond like that. And so there's the CH3, and here's the COOH. And as we look at this going down, this side over here is at the bottom, so the NH2 is going down, and on the other side the ethyl group is pointing down, so the ethyl group is pointing down like that. So this is the correct structure. Now you might have drawn that differently. I would follow what I've done now and leave it at that. Be very careful about trying to redraw it yourself in a different way. Practicing with this over here, I'm going to want to not, here I went down, up, down for the zigzag. Here it's pointing down, so I'm going to go up, down, up. This will be my COOH over there. And so when I'm looking at this, on this side over here is below the plane, this is above the plane, so the bromine is pointing down, the methyl group is pointing up. On the other side, this was the T-butyl group over there, and we've got this is on the top face over here, is the tosylate. There's just an H over there, we don't have to draw it in, so we draw out the tosyl group like that. All right, again, you might have drawn this slightly differently, but make sure, follow the process that I've shown you over here so that you get it right. It's very easy if you draw it back to front, it ends up drawing out the enantiomer and not the real compound. Right. And then the last two, just cyclohexane chair conformations, they are really easy to do. Just it does take practice. I know when you watch me draw, you probably think, oh, looks so easy to draw out the cyclohexanes. It takes practice. Do it a few times and it'll be easy for you then. They are on opposite ends of each other. Over here, if I go straight up, it must be the OH is going straight up over there. But on this side over here, up will be equatorial, because we know how to draw those out. You should go and follow. I always just draw the same chair structure, so I always use the same one. But if I'm going to draw the different conformation, I can't put the OH there again because there it's straight up. So I need to move it across one, so I'll just put it there, and then the OH is equatorial up. And I go across, and over this point over here now, the isopropyl group is pointing up and it's axial. So those are two different conformations. They're flipping between each other. You could draw, I'm just not good. You'll see I'll struggle a little bit more now. I don't draw it as fast. If I draw the other chair, okay, that's the ring flip, and if I did that, then I would put that there and the OH there. You can see it's very similar to this one over here. It's almost looking slightly different angle, but this is also completely acceptable and correct. This one over here, same thing. So we just draw out our chair. We can do both of them. Okay, try to keep all those lines nice and parallel to each other. So we keep it good, nice and parallel to each other. it helps if you're working in pencil, so you're going to make mistakes, you can rub them out. Okay, I'm going to put the ethyl group over there. Well, I shouldn't have done that. It's straight line. Ethyl group goes straight. I don't put the dashes and wedges. It's stupid of me. And over here, that's going to be axial up. And so if I want to do it differently, I've got to move things across slightly. So here, up will be equatorial, and over here, down. Note the angle. It's parallel to those two things over there, would be that one over there. So this is 1.5 marks, 1.5 marks, 1.5 marks, 1.5 marks, for a total of 6 marks over there. So just check that. I think some people might have not been marked correctly. So you got things were correct, but you were only given 2 marks because the Demi thought that it was half mark, half mark, half mark, half mark, but it's 1.5, 1.5. So just check that carefully. And then likewise, you must be able to go from the diagram to the flat skeletal structure. So that's a 6-membered ring over there, and start anywhere. It doesn't matter. The OH is pointing up, so OH is pointing up. Next one across, NH2 is pointing up, so NH2 is pointing up. And then we miss one, and again it's going up. It's up equatorial, so it's over here, and it's the ethyl group, like that. All right, so that's not too bad. This one also 6-membered ring, but this is actually a sugar, glucose. So yeah, we've got to put an oxygen in that place over there. Next door to the oxygen, part of the hemiacetal, which you should be able to recognize that functional group. There's a hemiacetal there. It's up, down, down. So down, down, and then down again, and this one is up, down, and up, like that. All right, and that should be 2 marks, 2 marks, and finishes off this tutorial. Good.